This video will show you how to write and deploy your NFT smart contracts. My name is Hakeem and I'm a Web3 engineer working for eBay. My mission is to educate you on Web3 development in e-commerce. So let's begin. First of all, head over to your browser and type in Remix IDE, which stands for Integrated Development Environment. Select the first link and there we go. So let me close this off. Here you can see the list of available shortcuts. So the compilation of the current contract, this is an optional thing. Generally, when you're writing a smart contract for the first time, you want to understand where the errors are as you're going along, as opposed to having to do it separately. So for this tutorial, we will be doing just that. And in the contracts folder, let's just select this. Let's delete all of this and rename the file to mynft.sol. Okay, so from here, let's define the Solidity version. So you have to define Pragma, Solidity. We will support after Solidity 0.8.0. And if we head over to the compiler, it has auto compiler selected. I advise you do the same. And we have a warning here, so SPDX license. What this is to handle legal issues in smart contracts. Since they're open source and they manage money, we'll need to add in a license. So simply head over to a new tab, type in SPDX Solidity, open the first link and just copy this, paste it into the top of your smart contract, and the error is gone, or the warning is gone. Okay, now we will need to import a few things. So all NFTs have to follow the standardized format of what defines NFT. Now this is what's called an ERC 721. So if we head over to the browser and we type in Open Zeppelin ERC import npm, what we want is this Open Zeppelin contract. Now Open Zeppelin is a popular Web3 software company that provision various Web3 tools. So they give standardized smart contracts, which is what we're going to be using now. They give auditing services, and they also give training academies for Web3 development, which is amazing. So let's just head down and take this example here. Import this, and we'll also need to import something called a library. So in the same contracts directory, utils/counters.sol. Now we can actually define the smart contract itself. So type in contract and then the name, so just my NFT. Inherit, so we need to inherit this ERC721.sol up here. So is ERC721. And now the constructor function is a special function in Solidity that gets executed one time and can never be called again. We are not going to use the constructor function of the contract itself, but we will use the ERC721 constructor function. Now, what does that look like? If we just head over to, again, another tab, and we type in, not this, but just Open Zeppelin ERC721 GitHub, and we head over to here, scroll down. So this is the actual source code of an NFT. So this is what it needs to inherit to be classified as an NFT. So if we scroll down, let's just zoom in a bit. I just realized it's quite zoomed out. And then we head down to the constructor. We can see it accepts a string of type. We can see the constructor accepts a string and another string, so a name and a symbol. And there's a special keyword here called memory. Now don't worry about what this means. It's just that Solidity has two types of memory storage. For now, we will accept the fact that it's a string and pass this through over in our contract here. So ERC721. The name would just be my NFT. and the symbol will be MNFT. Oh, and there is one thing I forgot to do. So we have this counters.sol library here. Now, a library is a contract that's already deployed to the blockchain. And the reason why it's so essential to use is that it saves you on gas. Now, gas is just a fee for computational power. And since a library is already deployed, what it does is it saves you having to constantly redefine a piece of logic in your smart contracts. And I'll show you what I mean just now. The syntax to use a library is using counters for counters dot counter, and then we have to do counters, and then we have to typecast this variable. So counters dot counter private, and then in Solidity the general way of doing private variables is to start them off with an underscore, so underscore and then token IDs. Right, now you'll see how this will be used in just a few moments. So let's define the actual mint function. So the minting will be when the NFT is first produced on the blockchain. So mint. The first thing that we want to do is to increment the counter. So we want to do tokens or token IDs dot increment. This will prevent NFTs from having the same ID. uint 256 ID equals token IDs dot current. These increment and current methods are already on the token IDs variable because they're being typecasted to this counters.counter library here. And then we can actually call the mint function. Now, before we actually call the mint function, we need to check what it actually accepts. Similar to the constructor function here, the mint function, so head over to the OpenZeppelin GitHub. We can just Control F mint. Here it is. So the mint function expects an address, which again is a Solidity type, and a uint256, which is just a number. So let's head back to the Remix IDE. An address in this case would need to be passed through. So in the mint function that we're calling, let's define a parameter of type address. We'll call it address, and we can't do that. It'll be 2. So address, so of type address, and the variable itself is called 2. Since we've inherited the ERC 721 contract, we can actually call the mint function directly. And if you noticed here, it is an internal function, which means that it can only be called from within itself. But because we're inheriting it, we can actually call it. So mint 2 and the ID. And then we just return the ID, so return ID. So just to recap, we have the license to prevent legal issues, the Solidity version, the imports for the ERC 721 standard, which is essential to actually make it be classified as an NFT. We have the counters library here, which prevents us from having to reuse and redefine code, and the constructor method to define the NFT's name and symbol. And we have our own mint function here, which is public, which means that it can be called from anyone and anywhere. It returns a uint256, which is just a number, and we're minting it to a given address, and we're returning, as I said, the ID itself. Okay, so in the compiler, we have an error here. So let me just add these brackets, and it's gone. Okay, so now we need to actually deploy the smart contract. Head over to this tab here, deploy and run transactions. So Remix gives you predefined addresses here and accounts, but if you want to actually deploy it to the Goerli testnet, let's switch over to the injected provider here in this menu. You'll be prompted to connect to a MetaMask. Just hit connect. Now we're connected and we can deploy to Goerli. It even tells you the network here. So let's deploy to Goerli. Confirm. And there we go. So you'll get this view on Etherscan link here. So click on that. Now we need to wait for the actual transaction to be approved on the blockchain. And there it is. So the success, your contract has now been deployed. Once deployed, you can head back over to the Remix IDE and click on deploy contracts, and you'll see the methods here. The ones in orange are write methods and the ones in blue are read methods. So these do not use gas, but the write methods do. And let's give an example of a mint. So I have my address here. Let's copy that, paste it in this function here, hit mint. We'll need to confirm it. Again, we can view an Etherscan to get the status of it. The transaction's now been approved, and if we click on the My NFT name here, it'll take us to the NFT itself, and you can see the token holders here. And there you go, that's how you deploy your NFTs to the blockchain. Obviously, if you want to do this on mainnet, this will cost real money, but the steps that I showed you just now is exactly how you would do it. So why would you want to deploy an NFT to the blockchain? And what possibilities can you have with NFTs and smart contracts? For more information, check out my recent video on the future of e-commerce. Thanks for watching, and I'll see you soon.